Welcome to MultiAxis Roughing, a closer look. This is Bob Delisle. This video was recorded as part of a live virtual class that we did back in 2020. The person giving this presentation is Steve Quitt, one of the senior application guys at Axis. So I hope you enjoy the video, and we'll talk to you soon. I'm going to turn it over to Steve Quitt.
Good morning. So what we've got here is a part. I'll give you some information about this part. Roughly, this plate is about 20 by 12 to give you kind of an idea of the size of this part. The other thing I want to do is I want to go in here and bring up, show you when I go underneath the angle here and go to draft angle, give you kind of an idea, basically this part, what we're dealing with here. So looking at the draft angle outcome, looking at this pocket here, the upper right corner, what you see with the white or the yellowish and then of course into the red is going from basically a vertical wall into an undercut, looking from the top. And of course this whole wall here is an undercut. So this would lend itself to be quite a difficult part to do with just 3 axis, looking from the top. The other thing to note is this surface on the bottom here, which we're going to be calling our floor surface when we're inside of the operation, is a multi-curved surface. So therefore, it's not flat. It's not something that you can approach by doing like a 3+2 and the normal to the flat surface, because of course it's got curvature to it. The other thing to show you here is we're going to be working with the stock model that is this, based on previous operations that were 3D operations, including OptiRough. So this is the reason that you see what you've got here. Also in here that we're going to be using with inside of the operation are the hold down nuts and bolts for this fixture. And as you can tell here, looking in the pocket, when we're running the OptiRough, it did remove some of the material in the pocket. But of course left considerable amount of material that need to machine. So with that being said, what I'm going to do is I'm going to go in and run this 5-axis rough operation. And as long as I go in here to the MultiAxis location and open this up, what you see is of course roughing. This, by the way, will be changing the name in 2021 to MultiAxis pocketing. And what they're going to do at that point is they're going to expand its capability and give you more options as far as how the machining goes. So what we're going to be running here at this point is going to be a bull nose end mill, 3/8 diameter with a corner radius. So therefore we do wind up with, and it's this one here, the 60 thousandths corner radius. So there is a flat, a little over a 1/4 inch flat on the bottom of this tool, just so you're aware of it and as far as capabilities of running this. When we take a look at the cut pattern, what I'm going to pick is I'm going to pick a floor surface. So I'll go in here and I'll select the floor surface, and incidentally, this is all solids that are on the screen. I'm not working with surfaces. I have been finding over the last 2 or 3 releases of Mastercam that solids work extremely well. And you don't have to worry about normals, because on solids, the faces of solids all have the normals pointing properly, which is extremely important when we're talking multi-axis. So I'm going to go ahead and select that bottom floor. It shows up as 1. Then for the wall and check surfaces, and notice that these are together, you don't select them separately. I'm going to go in here and I'm going to select by color. I have set up my model and colored my faces accordingly so that I can pick them when I'm doing certain things, in this case, this operation. And I'll go by color over here, and I'll select the purplish magenta color as well as the blue for the nut and the washer. And I'll select all those over here for colors. It highlights and shows you what you selected. So I'll end my selection. And it gives me 32 faces picked. I'm leaving 15 thousandths on those surfaces or faces. And then over here where it says pattern for machining, we only have roughing currently. This is where they're expanding this operation in 2021, where you'll have the ability to pick wall finishing or floor finishing. So in this case, what we're going to do is only have roughing, but we will be finishing the floor because I've left zero stock on the floor. And then the strategy for the shape of the pattern you currently have is offset from floor, which, as you see in this picture, all the motion and the intersections of the motion along the wall and what's going to be done with the pattern is going to be relative to the floor. The other option you have is offset from the ceiling. Notice how this motion now in this picture went, so now we're all flat if you had picked the top surface as being the ceiling and then down. So therefore you're going to have little areas over here that would just be where it'd be cutting. Or the other option, which is turns out to be one of the best options when you're doing this, is to use a morph between the floor. And notice what you have is you start out flat, and as you approach the floor, you then start to morph the tool path so that you then have consistent cutting all around with very little, if any, broken tool path cutting. What we're going to run is in its simplest form, I'm going to use offset from floor. And then the type of tool path, as far as how you're going to remove the material, you've got offset, which is like the traditional pocketing tool path in 2D or even 3D. And then you can go into dynamic, which is the same as the 2D dynamic pocket, or even OptiRough when it comes into looking at the spiral and the moving out and then not fully embedding the tool in the corners. So this is what we're going to use for this. You then go one way or bidirectional or zigzag. You can also go climb or conventional, and then you can machine by levels. Meaning, if you were going to go by levels, you would machine each pocket. If you had multiple pockets separated, you would machine each pocket to a certain depth, then move to the next depth and go back and forth between the pockets until you finished. Great for a thin wall application where you don't want to potentially bust out the wall by machining one pocket completely, which is what you have when you go to regions. Notice in regions, you're going to machine all of one pocket before you move over and machine all of the next pocket. In this case, we only have one pocket, so you're going to get the same results either way. Then we move down to the depth or the depth calculations and the depth steps that you're going to be taking. So what you have here is I'm going to just tell it a single slice. So with a single slice, it's going to go ahead and plunge in and then doing a helical entry down to the bottom and machine all of the material out with a single slice, using a step over of 1/4 inch. Remember, I've got the flat on the bottom, so I can still go ahead and take a fairly large step over. All the time that it's doing this machining, it's going to be staying normal to the bottom or the floor face that was selected. So let's go ahead and jump into this and let's create that motion. And then I'm going to bring this up and show it against the actual stock model of what was left in Verify so you can see it removing the material. So there's our tool path formed. And as I move this around, you can see the helical entry for plunging into the material. And then, of course, the spiral out, again, maintaining always contact with the bottom floor because we went with a single slice. So I'll bring up the material being the what was left over from the 3D operations. And let's go ahead and show you what the simulation is like here. I guess it'd be nice if you saw the tool. So this is taking a single cut and removing the material. Now, if you remember, we had a situation where there was an undercut, and of course, we're leaving 15,000 stock on the walls, which when you look at it being a single cut, it's based on the bottom. So you've got a lot of extra material left here on the walls, as well as, you know, material over here where the undercut was. And over here, we pretty much machined all of that because it was virtually a straight vertical cut as far as normal to the bottom. So if I wanted to go ahead and get a better definition, still taking only a single cut, but remove this excess material left on the walls, all I would have to do is to go down into the toolpath and change the iteration, meaning my number of slices will stay at 1, but I'm able to open up over here in the tree, I'm able to open up the cut pattern and look at the intermediate steps. If you run OptiRough, this is like the step up that you have capability of running. In this routine, what's called an intermediate slice. This would be the slices at the end of removing the material, go back in and run strictly finishing the walls that were selected based on this, in this case, 25,000 step. So let's go ahead and verify what that looks like so you get a feel for it. All right, same material we're starting with. We're going to do the same slice all the way down. And once we're finished with the slice, the depth slices, in this case 1, we'll turn around and then we'll run the intermediate slices, as you're seeing here, starting from the bottom, working up, taking that excess material that was on the walls. As you can see, we've got that all finished up nicely. Of course, with the material that's still left because of the 15,000s plus any we couldn't reach because of an undercut, we would need to come back with a finishing operation, something like a swarf cut, to remove that material on the walls. All right, so let's assume that that looks good, but that pocket's maybe deeper than what we want to take in a single slice. So then we go ahead and we take a look at changing the cut pattern to take, in this case, I'm going to move from number of slices, and I'm going to say, let's say I want to have a maximum of 400 thousandths. Maybe I have a cutter that has inserts, and that's most I can cut at one pass. So I'll change it to 400 thousandths. I've gone back in and removed the intermediate slices to show you what this looks like all by itself. So once again, let's verify this. And incidentally, if it's something that you're not aware of, I'm not closing and opening each time verify. I leave it open, sitting in the background. If you happen to have a second monitor, you can take and with that second monitor, put it off to there and just leave it open. A lot of people don't realize you don't have to close it each time. Just re-highlight your toolpath, and once you've got those highlighted and you call up verify, it resends the new information over to verify, so now you're seeing the new data being machined. All right, so here we go. 400 thousandths for the first pass up from the floor. Notice as I make this first pass, I'm not cutting all of the material because, of course, it's deeper than the 400 thousandths off the floor. That means my next pass will remove 400 thousandths from the floor. But in the meantime, this pass is cutting air. All this blue toolpath that you see with no removal of stock is air cutting. And as you know, air cutting is not a good thing to do. You know, just happens to be when the owner or the boss comes by and he sees the machine cutting air, it's not a good explanation as to why you're doing that. So what we're going to do is, this looks good. I'm getting 2 passes. But let's go back in and change up this toolpath so that we're still getting the 400 thousandths. But let's look at my depth step. We're going to also add a depth step to it of 20 thousandths, or excuse me, the intermediate slice of 20 thousandths. So this is going to do the 2 slices for the major roughing, again, not exceeding, for instance, our, let's say our insert in the cutter, or the depth that you'd want to go. But we're going to come back in and we're going to clean up the sidewalls with the intermediate step. All right, still have air cutting, and we'll get rid of that, and I'll show you how this routine can get rid of all that air cutting on the next iteration that we do. Again, we are also avoiding, and I could turn that on with the workpiece. That's showing us the bottom workpiece as well as the fixture. We are avoiding any contact with the nut, as well as anything else that would have been part of our fixture that we would have identified. So there's the machining of the intermediate passes. And again, to make a comparison with the 3D OptiRough, the little difference here is we made both depth passes and removed the material before we came back and finished any of the walls with the intermediate passes. This is a little different than the OptiRough, because the OptiRough will go down to a certain depth, rough that out, and then it will go in and machine just that portion of the wall. And then it goes down the next depth, removes the material, and then machines that portion of the wall. Whereas this waits to the very end of all the depths being made before it comes in here and finishes the walls with the intermediate passes. I'm not so sure which one I like best. They are different, and I don't know. In a way, I kind of like the separation between the roughing in this case and the full finishing of the walls. I think this will come to play a lot when we're talking 2021, where you can go in and basically do all the roughing and then come back and finishing the walls separately. Using, let's say, 2 copies of the operation, one doing the roughing, one doing just the finishing of the walls. So I think that's going to have a kind of a nice play to handle that. All right, so let's go one step further. Let's get rid of the air cutting. So if I go down in here to this iteration, inside of here, if you notice, I've now got the stock turned on. And what I'm using for the stock is the stock model that you've been seeing coming up on the screen that we've been verifying against. And I said before MultiAxis, and all I've told it is I just picked that and said to check the tool shoulder for collision, the shank for collision, and the holder. So shoulder, shank, and holder all checked for collision. The other thing that I changed in here is we're now doing a morph between the ceiling and the floor. And just looking at what the ceiling is that I selected, it just happens to wind up being this whole top face of the solid. This gives me a reference to say, start from this location, bring it down to the floor, and machine all of that in between. But since I'm telling it to use stock, it has stock all throughout here, this whole part. And if I were to let it, it would machine all of the material between that ceiling and that floor, which again, that can be looked at going all the way over here, and it would want to machine this whole part. So what I need to tell it is I need a containment. And I can have more than one containment listed as well. So the containment, and this is extremely important, unlike the containments you may be used to with 2D and 3D, this containment is 3-dimensional containment. So this is a 3D spline or a 3D curve going around the edge of this pocket. And the reason this is important is because you're running 5 axes. You're not running something that's relative to a plane like a 2D or 3D, so that you can have a containment out in space that's a 2D closed containment that lies in a flat plane. This can't be that. This has to be 3-dimensional, as you see. So not a problem. We have it to pick from. I've gone in and said, let's go with 2 slices. And my intermediate slices, I've set up, instead of a value, I've used a number. I said I want 10 passes. Again, you could bounce back and forth between how you specify this. The other thing in here, containment, we're good there. I'm not doing rest roughing. That's something you can go back in and machine with a large cutter, come back with a smaller cutter and have it only recognize where it didn't fit the big cutter and machine only those spots as well. Everything else looks to be the same. So I'll go ahead and let's verify that operation. And what you should notice here when this gets in here and starts to animate is we will not be cutting any air. It'll all be material cutting. So let me slow that down just a little bit. And you'll notice as we come in here, all of the tool path is cutting material. So we've eliminated the air cutting in this operation. So we've got a pretty good tool path here in terms of efficiency with no air cutting. This is a full 5-axis tool path, staying normal to the bottom floor surface or face, constantly changing to stay normal to it. What this also allows us in this case, because the tool is fairly small diameter, is that we have virtually finished that bottom floor at the same time that we've machined all the material. And give it just a second, and what I'll do is I'll get rid of the tool path, and then I'll show you in comparison within Verify. So let me get rid of the tool path. If I click on Verify up at the top and then go to compare, notice my coloration is set up to be basically about every thousandths. So green would represent between plus and minus 1,000. So let's go ahead and shade that, show you what was left for material in this pocket. The idea being is if we hit green, maybe bouncing a little bit out to the yellow or even the light blue, we're within the tolerances that called for. Now, you can't see the shading on the bottom because the part itself is actually turned on. So I can go over here and turn that off, and all you're seeing is the material and the coloration of the material that was left. So notice on the bottom, virtually all green, a little bit of yellow, just saying that we just bounced into negative 1,000. But that's all tolerance related. So I can actually come back to that and I can remove probably most of that yellow just by telling it to go a little bit finer on my tolerance. Notice over here, because of the lean of the tool being normal to the bottom, I've left material on that part of the wall. Plus I've left material over here because, again, the lean makes this an undercut and I'm not able to machine that when I'm staying normal to the bottom. So as I said earlier, we would need to come back and machine those walls with another tool path, probably something like a swarf, to get all of that material out of there. But what this allows is to give you some capabilities to control how you can remove material from a pocket situation using full 5-axis tool path. So this is pretty much what I wanted to show. Granted, very little time to cover anything in any great depth. We're looking to expand upon these workshops and make them into potentially longer and a little more of a training session about all of the parameters in these multi-axis toolpaths. This is something that we're planning for the future. The other thing I'd like to do in the future is to expand upon 2021 and the additional options that they give this toolpath, but that's, again, something down the road. In the meantime, I would welcome any kind of attempts that you use or successes that you have in actually using this toolpath, and would welcome that you send that in via email. My email, if you want to write it down for the future, would be stevek@axisinc.com, and that's AXSYSINC.com. And by all means, any questions, any problems that you have in trying to use this or any other multi-axis toolpath, please send it my way, and I'd be more than happy to respond to you.